take it away.
Okay. Thank you, Dave. My name is Srini. I'm from Citrusleaf. Essentially, I'm going to talk about high-velocity data. This is a problem that my co-founder and I, who's also here, Brian, say hi. So Brian Bukowski and I founded this Citrusleaf project a few years ago to work on the kinds of problems we saw in advertising. So I'm going to talk about what I've, in terms of using examples about high-velocity data and what it is that we've been working on, which has been turned out to be working. I'll try this. Okay, so well, I don't see the picture. I think the slides are not showing up right.
What version of, sorry, I saw the slides, I thought they looked fine, but
Yeah, they look fine.
apparently it's missing one of the slides.
Okay. So do you want me to?
Can you talk
Yeah,
without
no,
that slide?
Yeah, I can talk about the slide. So the first slide that you can imagine, it talks about what it is that we did with real-time advertising. So essentially in real-time advertising, you have a user typically trying to access the web page, and within some 100 milliseconds or so, you need to get to an ad. So what we can do, for example, what is required there is to find out what that user is interested in, and this is about display advertising. So which means there is a bunch of segmentation that happens, some data for the user gets stored, and then what happens after that is the system has to kind of make some decisions. All of that has to happen within like a few milliseconds. And that kind of performance is something which is hard to get if you want to also do a seriously consistent database, which is something Citrusleaf kind of focuses on, as well as make sure that system stays 24/7 and high performance and so on. So in terms of high velocity data applications, we've been focusing a lot on display advertising. And you can think of real-time bidding, there's a huge shift away from essentially trying to buy sites, visitors who go to sites, to actually knowing where the user is independent of the website that they are in, and then finding out where your users are. And in order to do that, you can't just use client-side cookies in many cases, because to do real-time bidding, there is server-side bidding going on against the same user by for multiple ads and so on. All of this again has to happen within the whole bidding process has to happen within 50 milliseconds or so for this to be realistic. And underneath it, there's space for a platform like ours, which is where we worked on to make sure all of those kinds of apps work. There's also a whole bunch of other related areas like social, gaming and social, as well as high traffic websites. We've actually deployed in pretty much many of these use cases already. Again, part of my slides are missing. I don't know what's going on with the. So essentially, on the left there, you can see a bunch of requests coming in, and on the right, I guess, left for you, is from various internet requests. And what this request happens is, if you look at the right side, you see a bunch of users, and each of that user is kind of known to the system. And typically you end up with about 500 million objects. You want to have hundreds of thousands of transactions per second. And the latency has to be less than 1 millisecond. And those are and the interesting thing here is, but each of those requirements by itself is not hard, but together is what makes the system particularly hard to do. To give you an idea, one of the deployments we've had, it's been running for over a year. What that means is it has scaled to 3 times the capacity. Software has been upgraded several times. It's basically a peer-to-peer cluster. There's no single point of failure. So the system basically has been running nonstop since September of last year and still going on. So that's the kind of, and it's self-managed, right? I mean, the other thing is what you can't afford to do is to have an operator do any work there. This is another kind of use case I want to talk about, which is the first use case I talked about is real-time advertising. Everything has to happen within a millisecond, right? This one is a little different. It's also an advertising use case. But what you want to do is every hour, for example, you want to find out all the conversions of advertising that has happened and look at, for those users, all of the data that they have, in terms of impressions that has happened over the last month or two. Now, that's a lot of data. You can't actually do the level of millisecond response time, use SSDs or memory for that. You end up storing a lot of it in rotational disk and then figuring out for those users. So what you want to do is on the hour, get a report every few minutes after the hour as to what happened, and then use that to to basically figure out what to do. what's happening in terms of trends. We started a campaign, something new is going on, you want to change something and so on. This is also something we've deployed. So those are only 2 use cases I'm going to talk about today. And then the basic thought I'd like to leave you with is, high velocity data is by nature mission critical. And what you need to do is to understand the recency of the data, and as the data becomes old, it becomes useless. So the system has to automatically kind of clean it up. People don't want to write scripts for it. So all of those kinds of behavior, the data comes in, you use it in a millisecond or a second or whatever, and then after a month, it doesn't matter. Maybe after 2 months, some data in your database may be expired in a couple of weeks, some within a few seconds. All of that is actually what makes this interesting and hard to solve. And the interesting thing which we have found in our Citrusleaf experience is this kind of application is extremely widespread. And and every day we're actually finding customers, because there are people who are actually building their own systems for this, and then they find that there's a database we can actually service this kind of stuff. It becomes very interesting. Unfortunately, none of my slides actually show up the way it's supposed to. I should have brought my Mac out. Sorry.
Okay, yeah.
I apologize.
All right. Well, thank you very much, Srini.